We are live. Hi. Got a few things to work on today on the agenda. I think we're going to start with the trajectory level loss for diversity is all you need to see if that gives us a nice exploration algorithm. We'll start with that. There is some C binding work to be done on the grid environment. We'll probably do that next. I need to do a little bit of work to see if we can integrate new curriculum learning stuff with that. And then we'll see where we go from there. I think there's some debugging to be done on the new replay buffer as well, because it works for some of the M's. It seems like it's fine for the simpler M's, but something's weird with neural MMO because it doesn't train anymore properly. So we'll have to figure that out. But yeah, that is generally the plan for today. I have 4 or 5 hours right now to do this, and then very early dinner, and then back for another 2-3 hours in the evening. That is the agenda. So when we left off here, right, we had this weird discriminator thing. I don't even think this should be part of the policy, really. Yeah, I kind of like the idea of this thing right here, taking this out of the policy. Oh, but then we have to do, yeah, the optimizer gets fiddlier, doesn't it? The optimizer gets fiddlier. All right, well, we'll hard code the size for now then, because we are going to have to mess with this size. Horizon. This. Yes. Okay, so here is the discriminator. We don't want these logits to get unbatched, though. And we want these logits to be structured. I'm just going to add them to the state for now. As I go, and just wanted to ask why you consider Minecraft not being a good environment to do RL. I think you mentioned some time ago. Okay, yeah. So one, and the biggest one, is it's really slow. Like really, really slow. Okay, let's say that you were to implement Minecraft like 1000x faster minimum, which you can actually do. That's like actually a thing you could do. Then you end up with the problem of it's not good for tabula rasa RL because there's not really like a clear defined objective. Most of the stuff that people do in Minecraft, they just do it because that's what they do in the real world, right? Like there's no reason to build a house. Like you can kind of dig a hole and you're good for the night, and then there's not really much advantage to building a house. So you kind of just end up with the mine portion, not the craft portion. And it turns into like a much, much simpler procedurally generated adventure game. It is really good for stuff like the task-based curriculum learning. There's this really nice paper, this like OpenAI paper on that, where you get diamonds just with a task curriculum. But like that would have been so much easier if the ends were fast. So it's kind of got two horribly bad things about it for that. Probably you're better served by NetHack on both of those fronts. The only thing Minecraft has going for it really is that everybody knows Minecraft. So that's pretty much it. Like as far as tasks go for RL intrinsically, it's a very bad one. And then the reason I don't use NetHack very often at all in my own work is yet more infrastructure problems. It's very difficult to run multi-processed or multi-threaded. Like you can't run other way around. You can't run a whole bunch of copies in the same thread. Infra is really king in RL. Infra is king. Design faster M's. There's a guy that actually has a version that's like somewhat faster that he's releasing, not as an RLM, as a game though. What's TPS? Ticks per second? Okay, that's hilarious. Huh? Is this a wrapper or a reimplementation? Oh. Yeah, that's not gonna work. Sorry, my guy. That's just not gonna work ever. Yeah, but you can't just wrap the existing game. It's too slow. Isn't it? Yeah, it is wrapping the existing game. It's not like a from scratch Minecraft. So this thing here, the state-based simulation for this is, at last count, 1.7 million steps per second on one CPU core. Yeah. And this is, I mean, this is like a real M. This is not a toy. Has an economy, you can buy and sell stuff. There's a lot to this. And like, I didn't even do anything special here. This is like pretty unoptimized, just like plain keep it simple C. There's no like fancy SIMD, like there's nothing. It's just real simple. Like these M's like this will run over 50 million steps per second. Very, very fast. Now that's a little bit overkill, but you do need to be able to train at hundreds of thousands minimum. And it gets worse when you go to multi-GPU machines, because if you want to, let's say, oh, well, we'll just scale it. Well, if you scale to 8 GPUs, you only have the CPUs on that machine to provide the data. So now, congratulations, you probably only have like 4 cores, maybe 8 cores, to provide all your data for each GPU. So speed is king. Speed is king. Honestly, I'd be way down to like, I would be down to make ultra fast Minecraft for RL if there were like, if doing that would also somehow fund all the stuff that Puffer wants to do, I would gladly do that. But there's not really a use case for it. learn stuff. The game through RL. Yeah, you're not, like, there's just no way that you're ever going to come up with that stuff. Like, think about it. Nobody ever learns that on their own, right? Like, everyone reads the wiki. I don't even think, has any person ever beaten that game blind? There's, like, unintuitive stuff that you have to be told to do, right? Like, you need the end, like, you need to go get the blaze rods and the eyes of end, like, to make the eyes of Ender to put in the stronghold portal, right? Yeah, that's a rough one. NetHack has similar stuff to it, but I don't think that bad. That one's really bad. That one's tough. And the thing is, like, even if you do that, like, Minecraft is not a hard game for a person to beat either. Agent. You still can't do it with the way, like, you need more breadcrumbs than you have, basically. I mean, I say that, but then again, Pokemon did work, right? We beat Pokemon. So, but it still required a lot of fiddling and hacking with stuff. We want stuff to work with way less fiddling and way less hacking. You know. What did I call this thing? Batch logics. What we're doing right now is actually kind of a cool exploration thing. So this is diversity is all you need. Well, my variant of it. We're trying to get one model to be able to conditionally do different things by training a discriminator that looks at trajectory segments and tries to tell if agents are doing different things. Without any guidance through PureRL, this is impossible. It's because people don't solve the thing tabula rasa either. So there's this really cool paper, I think from Polkit's group, where you can just screw up all the graphics in Atari, right? You can just like swap all the assets for random stuff that doesn't make sense. And people won't be able to learn how to play that at all, right? But the RL agents will just learn it as if it's the normal game. So this is the thing that people forget, right? When it's like, oh, well, it's hard, it takes so many frames to learn this game, or it's like this. No. Like, you're over-indexing on how much people already know going into it. Like, you can make the problem impossible for humans. And the RL agent will just do it like nothing's wrong. That's the cool thing with RL. It's superhuman at learning. At least a certain type of learning. Oh, come on. I had to reboot the drivers. And then we're going to get this trajectory segment stuff done. What I'm doing here is I'm going to swap the current model just looks at the logits of the current action. I'm going to give it the logits of the full trajectory. Or the full trajectory segment, rather. Or is this getting called? Right, so we don't need this. I want to remove this reward component, so it's only called during training. I don't think you need a reward. Nope, it's... What did I do wrong? 256 in. $256 in. That seems fine to me. Oh, right here. Alright, let's see how this looks. Very good. Okay. And where is the IDXs? I'm gonna just slice it for now, and then we'll clean this up. Yeah, I'm gonna just slice it for now. Ah, shoot, it's the wrong shape. Okay, we'll just take it from here. Yeah, that's just as fast, if not faster, than before. Does this do immediately better? I don't think so. See, the loss is so low on this that it makes me think it's kind of cheating. The loss is so low that it makes me think it's cheating. Yeah. Let's try to normalize. Let's try to normalize. Batch logits. You don't need to center it, do you? Maybe you do. But you can't just divide by standard deviation. How about this? I think we're definitely going to want something of this form, so it makes sense to go ahead and like fix up the code to support this. It's still definitely able to just immediately know, though. So I don't think it's actually doing anything because it's too easy. It's too easy for the discriminator. Discriminator is trying to figure out which, like, you essentially give it, you say your policy 1, your policy 2, your policy 3, your policy 4, and the discriminator is supposed to look at which is doing which based on its behavior. But the thing is, it has access to the logit distribution because you need that in order to backprop. And I think it's like using some weird signals in the logits to figure it out instead of like actually looking at the actions. And I don't like, you could technically learn it with RL, but you shouldn't have to. Okay. Let's at least clean this up so that it's like more feasible to do this. The only thing we need we kind of need a way to know which idea is assigned to which agent, right? You only have the N by D. Yeah, that's mildly annoying. Okay. I'm gonna actually have to think about this to figure out how we do this correctly. Guess we take this one maybe. Really don't need to record the batch at all. Indices. It's actually not clear how I do that. Maybe we look at this problem first. Why it's so easy for it to learn this. Okay, it literally hasn't even hit anything yet. And it's got this tiny loss. It has this learned like perfectly, right? 1, 2, 2, 3. 1, 2, 2. So 1, 2, 2, 3, yeah, and then 0. Then 3, 3. 3, 3, yeah, so it has this learned perfectly somehow. So the loss is actually, it's correct. But like how? Not the sum. I should learn this so easily. Literally with this, it's still doing it. Three, one, three. Literally, it just has the batch logic. It's able to figure it out based on this. And that's like crazy. What's this do to the policy, I wonder? Six. Wait. April 10th, 106. Yeah, that must be from now. Wait, 06. Hang on, is that? I'm not sure if that's the correct one. Model. Let's do this. Yeah, that's the wrong one. I thought there was something off about that. Maybe that's what happened before. Maybe I wasn't loading the models and I thought I was. Do a quick run of this. So this is, you only get to distinguish the policy from the first logic. It is actually %4. I'll do something. What action is it that we're doing? Up. We should see vertical separation. Not seeing it though. It's a decent enough policy. But I don't think I can tell apart which ones are which, right? You need like a harder objective for the thing if you want something that's really visually obvious, I think. Perfectly good policy, but it doesn't tell us very much on its own. Oh, also, isn't there are 4 policies, not 2, right? Yeah. Okay. Let's try something else. I know what I'm gonna do. Oops. All right, so we do like this, right? So we do mask this. Do this. Now you only get to see the logic of your most selected action. Ah, that's harder, isn't it? We get a reasonable loss. Now it's optimizing that loss. At least maybe we get something interesting. Let's run this for a bit. We're trying to create a scenario where like the snakes get forced to go to different spots or whatever. Really hard to tell these things apart. So this could just not even be an algorithm failure, right? This could just be like a interpretability fail. Okay, let's try something else. Now it only gets to see the logic of the first action. Might learn based on the zero state to, well, we'll see. I'm curious to see what this does. See what this does. They don't seem particularly predisposed to any one direction, do they? They're all still indistinguishable. I'm just trying to figure out some way to like give this thing a weak signal. Well, I can approximate it. Let's do like do something like this. Yeah, so I think before it was abusing the fact that it was start of episode to just like take one action. It's these things are like very, very good at cheating information if you let them. There's still some entropy in this as well. Good. So what do these guys do? The white and the gray ones are definitely going up, aren't they? For the most part. That's separation. The red ones are going to the right. Yeah, this is it. We got it. Almost. It's like, it's very close. You can almost see it. Hang on. I mean, this is like, this is very close to the result that we were going for. Right? How is it telling apart the gray ones? Maybe it isn't. Well, the red ones are clearly closer to the right. Yeah, the white and the gray are not perfectly separated yet, I think. But maybe we can tune that. We have the coefficient pretty low, right? The key is they've learned non-trivial separable policy, right? They didn't just learn to go that way and crash into a wall. They're still taking into account the reward. This might be too heavy-handed. The loss is low, but I think it's crashed the policies a bunch. We'll look at the policy regardless. This one might just be the straight go left, go right, whatever. So white is going down. Gray is going left and up, it seems. Pink is going right mostly. Yeah, so that's very close to separation, but the policy just isn't high enough quality to be able to tell. We'll try like this. I just want to get like a clear demo of this doing the thing that you expect. And it's very close to that already. I'd take like a 50 score cleanly separated one. I have to settle for this. 40. That's at least passable, right? Like this should be good enough to evaluate. I should do I should make the rollouts like skip the first 1,000 frames or whatever. Yeah, let's do that real quick because this runs way faster than it renders. First 1,000. Yeah, there we go. The red didn't find a corner. Policy is just slightly too weak, right? Okay, we'll go back to the original. It's sensitive to this scale, for sure. It's definitely sensitive to this scale. Go back to 0.10. Maybe we can even get something, maybe this is even too aggressive, right? Maybe the trick is to find something that is distinguishable without hurting the policy. Get out of here, bot. Loss is very high. Okay, so we know what this looks like. We get separation, but not super clean. Try a couple things. We go to 2.5. We give it longer segment, maybe. There's definitely separation. It's just not as clean as you would want. Also, the policies are not. You're harming the policies quite a bit. Okay, what if we give it what if we stop trying to make it so difficult on it, right? We give it access to the full log props of the action it selects. Basically, it just gets to know the actions that it selects. Okay, so this is very close to the performance of the original policy without this objective and with a very reasonable loss. But can you really tell? You can't really tell them apart, right? The model can tell them apart, but I can't. I don't see a clear directional bias to any of them. Maybe there is. Hmm. You don't really see it. I don't really see it. According to the model, these guys are playing differently, but we can't really tell. What happens when we increase the number of agents or the number of policies? If I try to do like 8, still tell them apart. Okay, so it's definitely harder for it to learn. Crazy how easy it is for the model to distinguish trajectories. Do you just train it with a bunch of dropout or something? I guess that's a thing we could do. That ought to make it way harder. it's still just going to crush this with 0.8 dropout, really. The loss at least goes up some. And the score doesn't get quite as high. Okay. Let's see what this has got. Holy. Did I do this right? To archive. Yeah, no, the colors should be consistent. I think that the gray and the white, let me just check what colors these are. So it's red, and yeah, okay, so these are paired correctly. Pufferbox, ISP, whatever. It's still screwy. Okay. That's all the agenda for today then, Captain. I'm trying to think what the hell to even do about that is the thing. Because I'm pretty sure it's the network. But I will have to go down to those machines in person today then. Yeah, I'm trying to get separable policies here. I mean, I think this is something. I'm trying to figure out. The problem is that the neural net is really good at figuring out which policies are different from one another. Like really good at figuring it out. I'm pretty sure that the white and gray are way more vertical, and the red and pink are way more horizontal in this one. X buffer refactor is done for now. It needs testing, because I think that there's still some things screwy with it. Well, there's a pretty obvious one, right? Now can't even access Bop 2, could this morning. I'm trying to think what I should do about it. I mean, I can go reset the network. That didn't help for shit last time. Well, maybe it was tail scale, I think we figured out. I think we figured out maybe it's tail scale. Yeah, because you SSH in fine here, and then it just stalls. Having issues on the box itself, though? What do you mean? Let's see. Would that go through tail scale? That shouldn't, maybe, I don't think that should go through tail scale. Just hangs. It shouldn't go through tail scale. It's very possibly the network. this looks what we're getting. Are you on a different network? Yes. The boxes have their own network. I mean, so that would be that would suggest that it's not tail scale, right? Since my box is fine. Unless for some reason it's not an exit node. I don't see anything that would screw it up. I think it's gotta be... The thing that I don't understand is like... Okay. See, now it doesn't let me SSH. I just got to the box. It accessed just fine, and then it didn't, and then it just stopped. So I think it's just shitty intermittent crashing ISP. It says the boxes are connected, though, all of them. So Tailscale can see the boxes. So what does this mean? I don't freaking know. Is something like hammering the network somehow? Where'd it go? You need the actual IP of it. Hello, welcome. Leave this thing up in the background while I debug these network issues real quick. Okay, I've got this thing. I am not a network guy. Losing packets is bad though. That's shitty. Alright, I'm gonna paste a few things into Grok like a moron, see if I can debug it real quick. If not, I'm gonna have to like finish up this work session and then go out there to debug, because I don't know what else we do with this. Just wanted to let you know. Well, I know, it's just like I'm trying to figure out what the hell to do with it. It's a really weird situation. And I'm not exactly a network guy. Wait, what the hell? It's just generating random crap. I pasted an image back and it generates... Okay, it just generated like weird garbage. Is it gonna keep trying to generate images? I'm gonna see if this works. I'm only gonna spend a couple more minutes on this though right now. And then I'm gonna just go back to this for a little bit. How do I get the router IP? The local IP of the router? Okay. ifconfig. Isn't that just localhost, or am I stupid? It's weird because it's like suddenly fast and then it like just locks up. And now it's just locked up. Lovely. All right, I think I'm going to have to actually go out to the machines in person to actually run anything on these because, yeah, this just doesn't respond from here. So I will do that. But I want to finish this research block up first since we have some folks here and this is kind of potentially cool here. So we have these two that look like they're going down and these two that are going up. These are distinguishable, right? My focus machine learning. Please guide me. If it's RL specifically, the quick start guide on puffer.ai is my general set of recommendations for newcomers. For general ML, like CS231N, the videos for that are online. Yeah, okay, and let's see, does this give us the same thing as before? Yeah, so this is similar. We've got yeah, these are visually distinguishable, right? So that's what happens if you really crank up the dropout. And if you don't crank the dropout, it's hard to distinguish them, right? Or no? Retrain. The goal of all of this is to come up with algorithm that gets you visually distinguishable policies. What if I just set the coefficient, hang on. What if I set the coefficient to 1, but then I make it really easy? Does that do anything? What if I set this loss coefficient to 1, but then I make this like way easier? That might be too hard still, we'll see. Like the score is going up, but very slowly. I'll look at this policy, then I'll try without dropout, and then I'll try something completely different because this is too much over optimizing on something that only half works. I mean, that should be a mostly okay-ish policy, 50. Oh yeah, I mean, that's distinguishable now for sure, right? So I'm a little unsure how, there's supposed to be 4 distinguishable policies, and I can only really tell apart 2. Archive. Oh, that's my bad. Yeah, that's my bad right there. Let's run this. Yeah, so there we go. That's actually perfect, isn't it? Look, they're literally each separated to one side. What happens without the dropout now is my question. Why is having... Oh, I just saw your thing. Why is having different policies that do different things beneficial? The idea is that if you can get policies to do like distinguishably different things, then A, you potentially help break weird self-play dynamics, and B, you also potentially get a general purpose exploration that should be way better than entropy bonus. It might be too easy without dropout. We'll see. you still get a lot of it here, right? These guys are still going here. These guys are going over here. These guys are going over here. And gray, I don't know how gray and red are different, but yeah, that's still definitely doing something. Now, what happens if you give it the full distribution again? Because right now we're not giving it, we've got like this mask. What if we do this? This might be way too easy. It's also the only one that hasn't really hurt the policy a bunch, though, because this is pretty much on par with the original baseline. 80. If I rerun this just to eval, they end up in the same spot. I see a lot of red up top and a lot of white and gray down here. Yeah, that replicates. That does replicate. So the next thing to consider would be doing something state-based, right? You can't back propagate through observations, though. Yeah, that's where you would have to add like a reward. I'd prefer not to do. What else could we use for this other than the full action trajectory like this? Okay, let me just write this out because it'll be more interesting to watch and maybe we'll figure something out. So what I'm trying to figure out here, right? You're in like a state, you get an observation, and then you take an action, and then you go to your next state, take your next action, right? And these go into your neural net, which is going to be an LSTM. So you have, your memory that goes like this. And ideally, we'd like to do, well, what we're doing right now is we're just taking these three actions and we're saying, hey, if you look at the actions of one policy, pi 1, A, and then you look at pi 2 of A, are you PhD? Yes. Pi 2 of A, then can you tell these two apart, right? You feed these into a discriminator and you try to predict, you feed these into like a discriminator D and you try to predict 1, right? And here, you feed these into D and you try to predict 2. You're just trying to predict, based on the actions, you're trying to predict which policy it came from. Now, the problem with this, right, is if you're predicting based on the series of actions, you fall into the trap of like the agent can just jitter in a specific way, right? Like any way that the agent has to communicate what policy it is to the discriminator, it will use. So if you encode it in the action, it can just be, oh yeah, policy 1 does the same thing as policy 2, except it jitters a little bit this way. Or, policy 2 does the same thing, but it jitters a little bit that way. So it's really not a robust mechanism for encouraging policies to learn something that is meaningfully different. I guess what we would want to do, right, is what we'd want to do is take like discriminator S and then S2, which would in general be Sn, so the first and the last state of a segment. This would be a pretty strong signal. There would still be some cases where the agent could cheat it. If there's like, for instance, if there's any flag that the agent can set in the observations, then it could just like set a flag or whatever. But a lot of the time, this should be more robust. This should be more robust. The problem is I don't know how we actually optimize this, because state 2 doesn't directly depend on the policy, and state doesn't directly depend on the policy, right? These are inputs. So we would have to optimize this with reinforcement learning. Which, obviously we're all set up for reinforcement learning already, but it's so much better when we don't have to add more reinforcement learning for auxiliary loss terms. It's so much better. I don't think we can put like the encoding of the state either. Like if we instead use the hidden vector for the state, then it'll just set the hidden vector to like just tell you what policy you're in, right? What policy it is. Heck, it's probably already doing that in the logits to some extent, right? Which is why we try to like normalize them. What's some good way that we can deal with this? Like, what is a good way to deal with this? I can definitely do it with reinforcement learning. I just really prefer not to. What if we also give it the state? Is there any indirect way that it learns to get to better state? No, there's literally no gradient path, right? So that is the tricky part. That is the tricky part, I guess. Is figuring out how to add this as a loss. Yeah, it's tough when like you only have the actions to work off of. That's still probably better than entropy, isn't it? Distinguishable action trajectories? Maybe. I guess maybe with dropout, it's harder to learn jitter. It's still pretty brittle, though. It's still pretty brittle. Yeah. What if we... I mean, we can definitely train the discriminator. That's not the issue. I know how to train a good discriminator on this. Like, you can train this discriminator, right? The problem is it won't affect the action distribution at all. Is there an obvious solution here other than just use reinforcement learning for this part as well? Like, I could technically do this with reinforcement learning, right? The way that you would do this with pure RL, right? So you train a discriminator on the first and the last steps of the trajectory segment. If the discriminator gets it right, then you add a reward. It's not terrible. It's not terrible. Technically, it's also not that difficult to implement, I think. And it shouldn't be that slow either. You just need to add... Would you share the network? I don't know if you would share the network. You could share the comp layers, I guess. You could also fully separate them. I think it's worth trying. Let me commit this version for now. so the discriminator is going to be a little bit more complex now, right? Discriminator. It's going to be something like this. The 16 channels. All right. Here's your new discriminator. And then we'll just do def scrim. And we're going to have to fiddle with this a little bit. I'm going to have to do that interactively. But the way that we want to implement this now needs to move. Actually, several things kind of need to move around, huh? Before you compute the advantages even. Oh, that's tricky. You have to recompute the advantages, don't you? Yeah, we'll do it. Anyways, don't need this anymore. And then we just do get this. This loss needs to be the reward as well. There needs to be a no reduction, right? Reduction equal none. All right, we'll try this. This is a mess, but we will try this. I'm gonna have to steer a little bit here, I think. Oops. Let me get this implemented and then I'll explain the idea. I need to at least get the initial version in. Shouldn't take long. This break. Seriously? One 28, 16, 11, and 11, right? Dummy. It's this. Okay. Cool. So the model works, and I just have to figure out this weird shaping stuff. Shape. Words equals words. So it makes sense to add it to the end of the trajectory only, I guess. This should be batch.rewards. Oh no. Yeah, this is just like a bunch of silly hacking to get this to work. We'll be able to clean this up a lot. Okay, that's the kernel compile. This should not be slow if we've done this correctly, because this adds like 1/32 of the amount of compute. Yeah, this is a tiny amount of extra compute. Okay. The problem is this loss is not decreasing at all, so it doesn't know, now it doesn't know what to do. So why is that? Oh, wait, this should be minus. I have the reward wrong. Doesn't make a difference. Yeah, I think it's just because that loss would have exploded if it had any influence. Either this is dramatically harder to learn, which it is, but like not learnable at all is a little bit suspicious, or I have the reward implemented wrong. So the idea here is that you give this discriminator the first observation of a segment and the last observation of a segment. And if the discriminator can tell which policy those two observations came from, then the policy gets a reward. So basically, the policy wants to act differently from the other policies. That's the goal. I might want to change. Try this one. That's a way clearer signal. That loss is still stuck though. We are optimizing it, right? Loss plus equal coefficient times loss, and here loss plus equals. And this is not inside of like a no grad or something dumb. You know, this is correct, but guess it's tricky. It's also possible I've just massively screwed up the reward computation, right? If I suspect that I screwed something up here, why don't I just do... if I suspect I screwed something up here as a first approximation, I can just do this. Let me think where I add it. I think I have to add it right. Integers dot shape. How's this 128 things? No, something's wrong with that. Oh wait, bash dot it. We do bash dot advantages. One. And that still wouldn't do it. It should be squeeze one. Still can't learn it. Yeah, that's the tough part. That is the tough part. I might need to just add it to the actual advantage calculation, right? So that would be it's got to be a better way of doing this. It's a really hard signal to learn from. I do this, like a filtering. That's probably just going to break it, right? that just breaks it. Is the first and last state really what you want anyways? I think it is. There's no other good way to encode, like, interesting stuff happened in the middle, right? Okay. What's, like, the most correct way I can implement this? I guess it would be as a pre-processing step, maybe? So if I put this up top, well, most of this up top, we do that. And then down here, we do the, we do this, maybe? State. Die and batch. Okay. That is doing something, maybe? The loss is different from before. Oh yeah, that is optimizing. Whoa. That's kind of crazy, right? I mean, it's distinguishable. It's kind of nice, I guess. You don't have to tune this loss coefficient anymore. You do have to still tune the reward coefficient, though, I think. It gives you one extra reward coefficient to tune. Go up here. Well, that's like the same as one food. We do like this. Now I don't think there's anything you can distinguish. I could log the accuracy, I guess. Oh, it does go up. 0.25 would be random chance. But it's really not that much better. See, now the difficult thing with the reward is you bias. You strongly start biasing the optimization. So this doesn't help. And if I do this, I think then it knows the trajectory, but it screws up the policy. Still only knows it 30% of the time, even with this, really? Okay, so that score is really low for screwing up the policy. I think what I want to do with this. Well, it's only 2. I need to move on to the next thing soon. But I'm going to try one last thing, which is I'm going to just clean up. There's one thing I wasn't too sure about. I might want to clean up. I think that actually should be enough to fix that one problem. Prevent it from changing mid-trajectory. Okay, that does actually improve the results quite a bit. Like, is that seriously it, though? This is as good as it does? Hang on, let's just do... Let's see if we give it like every 16th frame. Four. If this works. Not compatible. Yay. Okay, accuracy goes way up. Possibly too big of a reward magnitude here. Accuracy goes way up, though. Yeah, it's definitely too big a reward magnitude. Yeah, but now we're back down to it not being able to figure anything out. So it's very sensitive, it seems. It's just not getting that reward at all. Well, we're just gonna run this for 50 mil if this crashes, because this is about what we wanted. Okay. That's about as good as we're gonna get, I think, today on this. This is, well, let's at least see what the result looks like. Apparently this, half of the trajectories, it can tell what the model is. Because they have like a very strong directional bias. It's funny. So actually, they're not just going in one direction, though. They're all going in both of the directions, right? Definitely a funky strategy. That got almost the same reward, though, as before, didn't it? About this. The problem is you screw up the trajectories, really. Gets all that reward and it can still only tell it apart half the time. Yeah, see, the scores crashed to 50. Okay. We're gonna leave this thing alone for now. Definitely feels like we're onto something here. It's tricky because the action-based version you can learn directly, but it's very easy to exploit. And the observation-based one is hard to exploit, but it's very hard to learn because you don't have a direct gradient signal. 2 p.m. I'm going to grab a drink. I'm going to take a few minutes to clear my head. Then we're going to work on C binding stuff, I think, for PufferLib. So Puffer grid environment needs a C binding. We need to come up with some new API stuff for that. There's quite a bit to do there. I think it's very likely that there's some form of this that works, though. There should be some form of this. There should be some form of this that works, I would expect. All right, I'll be right back. Okay. Let's look at binding code. Num ems, num maps, map size, max map size. So the only thing here is max size, right? Yeah, the only thing here is max size. Max size, number of agents, vision speed. This is going to be same init on everything, really. So we can vec init this even. So I can grab that from Pong. Something like this, right? Observations, actions, rewards, terminals. You can pass truncations. Then you don't need this. All you need is max map size. And that'll be fine. Good. Size. Max map size. Then you do init grid. And that's about it. Now there's all this state code. Let's deal with logs first. You get to delete all this, and you just need this struct now. Return length score, and you need float n, right? You never reset the log yourself like this. Is there a tick on this? Yo, what you up to? Hi, Spencer. I'm adding the binding stuff to the maze and then figuring out how to do some fancy level setting stuff, which will be applicable to the driving sim as well. I'm also pretty close to having the dev branch cleaned up nicely. There's still some testing to be done, and I know that a bunch of the machines are a mess, so I gotta finish this and go figure out what the heck is wrong with machines. Much work to be done, generally. Much work to be done. Yeah, there's no tick, so I gotta add a tick. Decided to switch my ops to exactly match NYU. That's good. Can do that, and then we can always optimize from there. Mainly last few days, I've just been trying to ignore as much noise as possible and just get stuff done on this new branch of code. There's like a lot of algorithm stuff floating around that's like close but not quite there, you know? There's the log. Looking at ways to optimize my grid caching. I think it'll become a bottle when we start resampling for more maps. It could very well be. I'm really gonna just need to sit down with you at some point and like really dig into this thing. What is the current state of the training? Can you like train on multiple maps, or what's the current problem? .256 simultaneous 660K entity encoder takes 3 to 4 minutes to set up the cache in init. Yeah. Does it drive on those though? Like, does it learn well? Well, it should. Wait, struggles on learning when collisions were added only got a 70-ish% solve rate. Okay, yeah, it should definitely solve. Single map collisions, multi-maps. Okay. Yeah, so definitely figure out that. Once you have that set up, I mean, that's pretty close to like being able to replace the original sim. I think when you have that, we'll have to do some optimization and stuff, but that's pretty close. Yeah, we should chat about some stuff at some point soon. I'm trying to be around more in the evenings, but I've also just been streaming a ton last few days. Want to get fully solved first. 10 to 15x speed, yep. Next week should be last week for construction anyways, then I'll have full time to work on this. Perfect, because I might have even more stuff for you to do. Uh, what the hell am I doing? Where is this? Meeting a fun robotics company. Gonna pitch them some RL stuff. Awesome. So one of the things, and we should chat about this type of stuff. One of the things I'm thinking could be a good way to bring Puffer into industry that you actually might want to be a part of as well, would be to just like make some like really solid sims for specific domains. Like they have to look like that as well. So like you know the robot warehouse sim that you made? Like what if that sim were rendered to look like actual robot warehouse and maybe we made it either contractions or like finer discretized so it looks continuous, right? That would make a huge difference. Like the dynamics of that environment are not that far off of actually like being a warehouse, stuff like that. Hang on. deal with one thing. Yeah, but I think generally longer term, making it really easy to build sims is gonna be nice. I need to make terminals. This takes a seed that it doesn't then use. Literally doesn't use the seed. Here. Render global, I think it is. Undefined symbol render. That's weird, right? Maybe it's just cached. Yeah, it's cached. Alright, I gotta fix that. How we do that? Unknown. You need the all right. Vecnet requires just do max map size. Wait. I thought I had this right. Observations, actions, rewards, terminals, truncations. Numems. You forgot numems and seed. Int no attribute reset. And pretty much all this should be like the same as before. Right, this should all kind of not change very much. Back step, back log. That's pretty much it. Now that's just fixing other random stuff from dev. Oh, am I not using the policy here? Wait, default. No, we should have shouldn't be using the default policy. That's weird. Hey, welcome. Oh wait, this should be grid. No. You. I think I probably just changed the API. Yes, that no longer returns that. You have one error. There's going to be, there will be many errors, I'm sure. Many to be fixed. There you go. Now this still isn't going to work. It'll run, but I don't think we're going to get much back from this. And now we have to figure out the map loading and saving and all of that stuff and how we're going to deal with it. That is the main thing. So this is one of the environments where we have a fair bit of stuff in the Python. And the main thing is that it creates these states. And then these states get shared. It's a little trickier. I could do like a global init or whatever. The thing is, this gets called every time reset gets called in this code, which is hard to do. Let me look at how Aaron needs to use this as well. I should be able to get this code 1 second. So Aaron's been working on curriculum learning in Puffer. And he's got most of it in here. He still has this state. He kind of needs to know how to set and get states. That's tricky. Let me see how his sampling works. So task is done, you logged some stuff. Then gets reset with levels. And then when you call step, you give it self.levels. So I think it is just like a random. Is it random uniform over these levels? I think it is. That's not that hard, right? Oh, and then these levels have a probability or whatever. No, it looks like he was experimenting with cumulative prob, but now it's just a random choice over levels. Either way, we can support something like that, I think. I mean, really all you need is a shared init. I'm trying to think if that's good enough. In fact, I think it's even easier than that potentially. I can just give you like a shared create function or whatever. And then that covers almost everything. No, I think that covers everything. Yeah. You'll need a way to unpack different data types. That's not hard. You just need a shared create. Okay, well, I've got a little bit of time to start on this right now, and we'll finish this after dinner, most likely. Very early dinner today, but I think I have a little time to start on this. So the idea is you also need to pass. Why does this take args like this? Empty args? That's kind of weird. Well, regardless. I can have here something like this. This actually needs an implementation. But they might not define this. It's not one line for no reason. In fact, I don't even think you need this bound whatsoever. You just need this extra function, I guess. And go after logging. And this doesn't even unpack. Doesn't unpack the env at all, right? Yeah, this doesn't unpack the env at all. This is just going to call your code. This needs quarks though, doesn't it? Yeah, this does need quarks. Oh, hang on. Alright. So you have to unpack anything? No, nothing. You literally just call your function from this. And all I have to figure out is how to... This returns pi object. How do we do it when we create the env? I think it's going to be the same as env init. So this is your env here. Pi long from void pointer. You need to know the type of object this is going to be. Unless I just void star it. Void star. This doesn't take env. You can error check. Oh, we don't want to overwrite the error. Maybe it's literally just this. This seems really pointless to do it this way, though, doesn't it? Like when you can literally just do this. So we do it just takes args and quargs. And then you could do something like so we do int num ends. Right? And then we do state star all right. So this gets you state. Literally just that, isn't it? You just define this thing. Yeah, and then this gets defined over it, right? So you get rid of this, and then you just bind something like this. This takes numems, so then we do it's just this. Let's see if we can get that to run. the annoying caching thing. Conflicting types. PyObject. Alright, that's yeah, I gotta go grab food. I will be back in about an hour, and goal will be finish this, some additional testing on some other stuff, various miscellaneous dev, hopefully getting to cluster maintenance as well today. A lot of stuff to do, but good progress overall. So for the few folks watching, Puffer.ai for all my stuff. Start the GitHub to help us out. You can join the Discord to get involved with dev. This is all open source, contributor led.